Last episode, you found edges, Sobel gradients, and canny outlines that lit up where pixels change. Edges are lines, but ML wants objects, how many cells, how many parts, how big is each. This time you cross the line from pixels to a countable, measurable list of things with threshold and contours. Start with the truth. An image is a grid of numbers. Here's a 60 by 80 grayscale canvas, mostly dark, values near 0. We've painted 3 bright rectangles onto it, each a different size, each a solid block of high values. To a human, 3 shapes. To OpenCV, still just numbers. Thresholding draws a line through those numbers. CV2 threshold with a cutoff of 127 says anything brighter becomes pure white. 255, anything darker becomes pure black, 0. The gray gradient is gone. Now every pixel is a clean yes or no, foreground or background. On that binary mask, CV2.findContours walks the border of each white region and hands you a closed loop of boundary points. 1 contour per blob, 3 blobs in, 3 contours out. Each contour is a polygon you can wrap a box around with bounding rect or measure directly with contour area. And that's the whole trick. Count the contours, that's how many objects. Measure each, that's how big. We sort them by area and we've built a tiny feature table straight off the pixels. Object width, height, area. No neural net, no training. Just threshold, find, measure. Here's the program. We seed a generator np.randomDefaultRNG7, make a black 60 by 80 canvas, and paint 3 filled rectangles of known sizes onto it with NumPy slicing. Deterministic, every run draws the exact same shapes. One line does the segmentation. CV2 threshold IMG 127 255, CV2 thresh binary. Pixels above 127 go white, the rest go black. It returns the chosen cutoff and the binary mask. We keep the mask. Then CV2 find contours on that mask with RATR external, so we only get the outer blobs, and chain approx simple to compress straight runs into corners. The number of contours it returns is literally our object count. We loop the contours, call CV2.boundingRect for width and height, multiply for area, and collect them into a Pandas data frame, sorted by area descending. Pixels became a table. Run it. The terminal prints the contour count, then the sorted feature table, 3 rows, each with its width, height, and area in pixels. Then the total foreground area summed across all 3. Last line is the contract. We run the whole pipeline twice and assert the area lists are identical and assert the table's largest area equals the headline number. Seeded shapes in, the same 3 measurements out, every single time. Threshold splits numbers into yes or no. Contours wrap each yes region into a countable, measurable object. That's pixels becoming features. The bridge from images to rows in a table. Next episode, we cross every bridge at once. The capstone, one seeded end-to-end ML-ready dataset, from raw numbers to a trained and checked result.